please give a big applause to smart contract engineer at Delphi Digital, Gabe Rodriguez.
Thanks. Hi there. My name is Gabe. I'm a contract dev at Delphi and a contributor to Mars Protocol. Late last year, my wife and I were on a road trip in northern Italy and found ourselves driving through Turin and ran into this light. Right? My first reaction is, this is an invalid state. How is this possible? All right, by show of hands, what should you do? Should you go through the light? Who would go through this light? Proceed as normal. All right. Who would stop? We should immediately stop. All right. You were as risk averse as me because I just sped up and immediately discovered a red light and almost caused a car crash. It's funny, in Turin, it's a well-known fact that some of the lights are not up to standard since 1993. But for the sake of this talk, let's pretend that that was an invalid state. It was not intentional. So for the devs here, it's not difficult to imagine how you would encounter a bug like this, right? Let's just say we define a global key value store. Each one of the lights correspond to, let's just say, our view layer, which is the light. We flip the Boolean on green, it's true, yellow, red, and so on. And then we have services, right? We'll have services that are accessing this global state. The timer service, the one that you would expect that just waits 20 seconds, flips green from true to false, yellow to true, yellow to false after some time, red to true, and so on. We have a second service. We'll call it the construction service. They want to blink, right, the yellow light. So what do? They just flip the Boolean for yellow, true, and false. We'll have an emergency service as well, accessing this global key value store, flipping red, true, and false. They want to flash the red light. And we'll have a maintenance mode or maintenance service that is flipping them all to false. Different consumers, different times, mutating this global state. I think the developers probably know where I'm going here. One day, the construction service is using the store, flips the Boolean to true, leaves, and then the timer service resumes. Boom. You've got the Turin bug here, right? For developers, we know what this is called, right? Shared global mutable state. For whatever reason, it terrifies us that bugs like this can arise by using these patterns, but we gravitate towards it by default for some reason. It is brittle, right? There's no inherent security properties with it, and we have to be very vigilant with guards and if clauses and edge cases to prevent getting wrecked. But we see global mutable state very often, right? And unexpected state changes in the wild. Let's just say you're using an appliance, you're clicking a series of buttons, and you find yourself in a place that you can't get out. What do? What's the human reaction for being in an invalid state? You just turn it off and turn it back on again, right? So the router, everyone knows this, always gets into some weird global state somehow, and we just reset it, trying to get back to normal. Grandma, she's having an issue with her computer. You don't tell Grandma's shared global mutable state, of course. Now you say, just restart the computer and try again. We're trying to get to a state and not be stuck in some invalid state. Unexpected global state is the reason why we can beat Super Mario World in 42 seconds, right? Under the right set of conditions, Yoshi should not be able to eat a coin and fast forward to the ending credits. For those who played Pokemon growing up, remember catching missing number? By catching missing number, you would mutate the global state in such a way that from that point on, you would encounter very strange bugs and glitches. But a good side effect is that you can duplicate items as much as you want, perhaps with the side effect of crashing the entire game. Front-end developers, I don't know if there's any front-end devs here, but the browser window object is the OG global mutable state object, and we've abused it in the past for so long. In fact, your web wallets are often using, if you go to window.ethereum, it looks like MetaMask and my computer and Phantom are simultaneously accessing and mutating this global state here. Is this why MetaMask is so buggy? We will never know. Another front-end example, you see a loading screen, and then you wait a little bit and you get an error. But the loading indicator is still going, right? The person who developed this did not put the safety guarantee that they wouldn't get into this invalid state. It's an unexpected state that shouldn't be there. It's not loading, it's in the error state. This is the front end of Mars protocol. It is difficult managing state. in front ends. When you land on this page, 90+ requests occur. And managing this is the job of every one of these new fancy state management libraries. But in my assessment, the vast majority of these are just variations on a global key value store that you mutate. But for the worst part, if you're in a browser, you can refresh. For blockchain, without hard forking, we should, for all practical purposes, consider that there is no refresh button. We basically need to adopt safety patterns, right? Patterns that have high safety guarantees and implement that as we're programming. Enter finite state machines. All right, this is an old idea in computer science. This is nothing new, but I'm here to try to convince you that we should be using these patterns more often in our code. It's a different way of modeling and organizing your applications. We'll go back to the key value store, right? Traffic light state. How would you model this as a finite state machine? Well, it's simple. You have nodes, which are the different states, red, green, yellow, and you have the edges of this directed graph, which are the events or transitions between these different states. The states are tied, bound to the view layer. It lends itself well to visual modeling. It's deterministic. There's documentation that's automatically that you get. It is pretty beautiful. But what about the Turing bug, right? The yellow and green simultaneous light that shouldn't occur. Well, you can model that as a state machine very easily to avoid by having nested machines, right? You have the normal machine on the left there, but now it can emit an event, emergency, and move to the emergency machine that just toggles red and off, back and forth. The Turing bug is not representable in this kind of way that you modeled the state machine. And I'm not the only one singing the praises of finite state machines. ChatGPT is too. I don't know if that's a legitimate source, but maybe we should consider the opinions of our future overlords, should we not? Going back to these state management libraries, there was a library that stands out, in my opinion, for introducing a different paradigm of managing front-end state than the rest. It's XState. I'm not sure if any of you have used it. I was surprised to see in the top downloaded React libraries as of a couple weeks ago, XState was number 3. And their paradigm simply is to represent your application logic in this JSON-like format with the different states and transitions between. And they have this cool website, stately.ai, that you can just paste in your state machine. And when you paste in your state machine code, a state machine is manifested in a UI that you can simulate and play around with and mess with, which is super cool. In fact, you can even go the other direction with Stately. You can model out your state machine and all of the logic and expected transitions between each, and it generates XState code, which is really cool. And once you get into finite state machines, you realize this pattern is very helpful for modeling basically like anything. There's a very vast design space for what can be modeled as a finite state machine. Here's an example of parallel state machines for font styling. Another example for elevator logic. Someone constructed all of the logic there as a state machine. Form handling. Someone created a state machine, or a complex one, to represent their entirety of their UI. Right? Why would they do that? Well, some of the React developers that might be out here are very familiar with this pattern. I think use effect is my greatest enemy. The natural patterns and tools that Reacts give you does not lend itself well, in my opinion, to debuggability, determinism, and in fact, the control flow of this logic is quite difficult. But if you model the same thing as a state machine, it's very deterministic, easy to debug, predictable, and the expectations are right there. Yeah, once you get into state machines, you start realizing state machines are everywhere. Half the flowcharts you see in Reddit are state machines. The original Super Mario World manual on page 11 describes the possible states Mario can be in as a finite state machine. I don't know if anyone plays Overwatch here, but the developers at Blizzard created a state machine-inspired programming language to model out each of the characters' actions and behaviors and side effects within the game. Even protocols can be represented as state machines, and aptly so. Props to PyDAO, who put this on the front page of their documentation to describe how all of the systems are interacting. And then shame on me, there should be another slide for, this is a Cosmos conference, Tendermint. Tendermint can also be aptly described as a finite state machine. If you like very interesting, vaguely reassuring state machines, you can follow them on Twitter. But let's get to Rust, right? There's probably a lot of CosmWasm developers here who have likely also been red-pilled on Rust, just like I am. I used to hate the compiler, then I got Stockholm Syndrome, and now I am in love with my captor. It is a really cool language, and it's very good for modeling out finite state machines. And what's the reason why? Because the enum type, right? Enums in Rust are extremely powerful. In other languages, enums are just identifiers. But in Rust, you can do some really interesting things. One, you can implement methods, right, on Rust enums. So that means as well, with Rust pattern matching, if you add a specific variant with a pattern match, the compiler will throw unless you handle all of those edge cases as well. Pattern matching, method implementation, these things lend themselves really well to modeling out something like this. So in this example, how would we model out a traffic light as a finite state machine in Rust? All right, let's define some state. Red, yellow, green, the only possible states our application can be in. And let's just implement next, or a toggle of some type that allows us to know, okay, from this variant enum red, afterward goes green, and so forth. It's very easy, self-documenting, I would probably say, and easy to reason about. But the Turing bug, right? How would we make sure that we can define a state machine in Rust where the Turing bug is not representable? Well, we have to introduce a new concept with Rust. It's like fat enum, some people call it. Rust can have data associated with each variant, and they don't have to even be the same type, because with the exhaustive pattern matching, you can see in the area right there, Rust has able to destructure and inspect the different types and enforce it. Type-safe data association with enums. It is beautiful. It is also the foundation of the option and result type in Rust, which, chef's kiss, amazing. Okay, let's go back. How would we represent that two nested state machines? Well, we have a mode, right? Emergency mode, normal. We associate them with two different machines, the normal mode and emergency mode here, that are also associated with the only states that the machine can be in. And then we implement a few new methods. So here's the normal mode. We implemented new there, so you know what state that you begin in. You're familiar with the next, the toggle mode, and then a new emergency mode that allows you to get into the next machine, for which we implement a few more methods. New, you start in red. Next, you toggle between red and off, so it's blinking. And then end emergency, that allows you to get back into the normal mode. Goodbye, Italy. It is not representable here. In your contracts, there's probably some CosmWasm devs. You might realize sometimes it's called an admin role or an ownership role, owner role. You need to be able to have an account that has elevated privileges on your contracts. For Mars, this is via governance. You need to be able to change some of the asset parameters, whitelist, delist assets, and so on. And we realized, and you might get this feedback in some of your security audits, it's quite difficult, and you got to be very careful to transition this role, right? If someone fat fingers a wrong address, this role is sent out to some place that you can't get it anymore, and maybe your contract is borked at that point. The proposal, proposing a new owner, accepting the role, clearing this lends itself well to a finite state machine, and we implemented it as such because we wanted this high safety guarantees that invalid states are not possible. You can download this library for yourself, for Mars owners. If you get a security audit and they say, hey, you're not doing the proposal acceptance role for your contract, you can use this as well. I tried uploading this, or upstreaming this rather, to CW+, and I got some interesting feedback from a very good CosmWasm developer that said, hey, this is kind of complicated. Why don't we use a key value store? And I think to some extent that's true. Not all problems can be modeled so well with state machines, but there's something that I think it was missing in the code, which is the visual formalism that you need. Xstate really understood this. So I copied the entire Rust package for the owner package that we created, sent it to ChatGDP, told it to give me some X-state code that represented my Rust package, and voila, it gave me this beautiful interactive state machine that I could have concluded in my pull request. So finite state machines are not the answer to everything, but I'm here to convince you today it should be something that's in our toolbox and our toolkit as developers that we use more often, especially for coding in Rust. Thank you very much.